Hello students, this is a class of control system. In this class, this is the continuation of the previous class. In the previous class, I have discussed about the basics of control system. What is actually a system, what is the control objective, and the purpose of working with the control system. So, carrying on that lecture, in this lecture, I will be discussing about the different types of control system, the two basic types. That is, one is open loop control system and another is closed loop control system. So, at the onset, let us first discuss about the loop. What is a loop? As all you know, loop is basically a closed path which can be formed starting from a particular point if we move without changing any direction in a particular direction without changing it. If we reach once again at the same starting point, the region which is being enclosed by this process is generating basically a loop. So this is basically a loop where the starting point and the finishing of the ending point is the same, which is enclosing a particular region. Now, if this is a loop, considering this concept of loop, the basic classification of control system is basically open loop and closed loop. That means any control system which is having this basic loop in its configuration is having, we can say that a closed loop control system, and any system which is not having any such concept of loop is open loop control system. That means no loop is formed, no loop is being used, and it is open. So in today's class, I will be discussing about the open loop control system, and in the next class, I will be discussing about the closed loop control system. So let us first have a focus on open loop control system. So this is the basic block diagram of open loop control system, where I have shown the different basic system elements which is comprising this open loop control system. Now the two basic elements, very basic elements, which is very essential to form this open loop control system is controller and another is controlled process. So one is controller and another is controlled process. This controller can be the brain. We can say this is the actual brain of this control system. That means the intelligence of working with open loop control system, the overall intelligence of the system lies with the that is confined with this controller. That means if we, for example, if we use microprocessor or microcontroller or any other type of controller, any type of amplifier, any type of signal processing device, any type of filter, any type of adaptive filter or others, this controller can be such type of devices which is the main brain of the working of this open loop control system. Now this controller must always be having some reference input. Now for mathematical purpose, all these parameters which is defined, all these parameters which are defined in this system, in this open loop system, is marked with a particular system variable. So this reference input is marked with a small r. Then this reference input will be used for the controller, and having this input, the controller will be generating a signal at its output port, which is the actuating signal. That actuating signal is designated by U. Now a small u. So this actuating signal, what is the meaning of actuation? Meaning of actuation means to make it happen. That means we need to reach to the desired objective of working with this system. So more and more we reach to the desired objective, we need some signal, we need some driving force which will be driving us towards the desired objective, and that is the meaning of actuation. That means to make the actual things happen, to bring us to the actual output, to the actual response or the desired response. So this actuating signal will now be working, will now act as the input of the next block of the which is the system element, which we will be calling controlled process. This controlled process is sometimes called planned. This is called planned. So this is planned or process which is under control. So we are in the process of controlling one or more of the parameters of this planned or process by the help of this controller. So our objective of working with open loop control system is to control any single parameter or more than a parameter behavior of this control process or plant with the help of the controller's actuation. And controller's actuation is controlling the working of the controlled process. Now this controlled process will finally, after processing the required variable which is under the scanner, which is under the control by the controller, will generate finally a controlled variable denoted by C. So this is the basic block diagram of open loop control system, where the two main system elements are controller and control process. Now what are the features? Let us discuss about the different features, basic features of an open loop control system. You can see there are a number of features. The number one is no effect of output on input. That means, since this is the major thing of this all about this open loop control system is, it is the number two, the point number two, without feedback operation. That's why there will be no effect of output. There will be no effect of output on the input. That means feedback means, we all know that taking a replica or taking a sample value from the output, and if we bring it back to somewhere at the input side of the system, that should be called, that topology should be called a feedback. I repeat, taking a sample or replica from the output and bringing it back to somewhere at the input side of the system generates a feedback. That is called a feedback. So in open loop control system, it is without feedback operation. That means here such type of feedback connections are not required, are not present. That's why no loop is formed. You can see, if had it been a feedback here, it is basically a loop. If the loop is created, had been a feedback created over here. Since there is no feedback created over here, so there is no question of loop being formed. That's why without feedback operation it is happening, and therefore no effect of output we can say on the input. Output will be independent of the input, and input will be independent of the output. There will be no direct connection between the two. Number three is, since it is working in such a fashion, there is no direct relation connection of direct influence of output on input. That's why we can say there is lesser scope of input correction in response of sudden unwanted change in the desired output. That means, if for any external disturbance, any parameter variation, any input variation, unwanted input variation, if there is a change in the desired output, and if it is sudden, if it is unwanted, then there will be no scope of input correction. Because of this sudden unwanted changes, there is no scope of input correction. Why? Because there is no directly connected in other way from the output to the input. That means there is no direct feedback. So therefore, there is lesser scope of input correction. Now point number 4 is, considering all these aspects, we can say the designing of a open loop control system is simple and economic. It is cost friendly. Now let us take an example. Let us understand this theory of open loop control system with one or two real life examples. Let us first take an example of bread toaster. We generally use toaster in our home for toasting breads. So that toaster, the working of that bread toaster can be called a very good example, very good real life example of open loop control system. Let us see. This can be formulated in this way, that the command input which is given to the reference input element in the tester, and reference input element is generating the reference input into the dynamic unit. Now this dynamic unit is nothing but the forward element of the bread toaster, which is nothing but the heater portion. That means the bread is being heated to give us a certain amount of crispness, the certain amount of color, certain amount of texture, darkness, and that is being happening by the heating of the bread inside the dynamic unit of the tester. So that dynamic unit is the forward element in terms of control theory. We can say that, and that dynamic unit will be giving us the final output. Now, if this is the basic block diagram for a bread toaster, here we can say in the language of control system, the set point is desired darkness of toasted bread. That means for any bread toaster to work in this fashion, we need to first set up the timer inside the system. That means how long the bread will be toasted. That timer setting should be done initially before starting on the operation with the bread toaster. Now that set point is nothing but the temperature at which finally the bread will be toasted, and that is the set point. That will be directly indicating how much desired darkness of toasted bread we need. As per the desired darkness of the toasted bread, as per the desired crispness of the toasted bread we need, we will set up the time in the toaster. So that is our set point. That will be working as the reference point. And finally, when all the process is happening, when all the processes end in the bread toaster, finally, once we are getting the final output, what we will get? We will get degree of darkness or crispness of the toasted bread. That was our control objective. That up to that much level, the darkness or the texture or the crispness of the bread we need. So that is the final desired output. And for that, the command reference input was our timer setting. And based on that, the heater will be on, and that will be heating continuously the bread which is being inserted inside the machine, inside the system. Now in this process, the two other things are forward element of plant. I have already mentioned this dynamic unit is having the core device which is the heater, and that will be generating the heat which will be used for the toasting of the bread, and that is the forward element of the plant or the process. That means this one, this thing is the dynamic unit, and that is the heater. And finally the reference element is timer unit. Reference element or the reference input which is being to the controller. That means this timer is nothing but this portion, this element, the controller here. So that timer will be operating up to the set point, up to the set time, and according to which the bread will be getting the proper color, the desired texture, desired crispness and hardness or darkness. So this is how we can say that this example of bread toaster is a very good real life example of open loop control system. Before I conclude, I can also exemplify with another very common example of open loop control system. That is, when we wait in a vehicle in a traffic junction. Suppose we are having four corners of a traffic junction, and where the traffic light is being operated. For a certain amount of time, the traffic light becomes green, and for a certain amount it becomes red, it keeps red. So it happens with the help of some set time by the traffic police, by the system, by the process, that for a certain length of time it will be green in a certain direction and it will be red in that particular direction of traffic, irrespective of the rate of traffic moving in that direction through the junction. And accordingly, we all know when one direction is red, the other direction will be green or yellow, and when that is red, and the previous direction will be green or yellow. So irrespective of how many numbers of cars or buses or other vehicles are moving, that means the varying rates of traffic are accounted for in this case when the timer is being set for that particular junction to movement the flow of traffic, to control the traffic flow in a particular junction in that particular direction. So this is also an example, a very good example of open loop control system, where how much traffic is moving and how much traffic is reverted back at because of the red or green light, intermittent red or green light changes, that is not actually dependent on the number of vehicles crossing or passing through the junction, or unaccounted for the traffic, unaccounted with respect to the flow of traffic. Actually, the main thing is the control by the timer, up to which particular direction will be either red or green. So this is all about the open loop control system, the two real life example and the basic features. I hope you have understand through this lecture, and it will be helpful for you for further studies. Thank you for listening and watching.